Cool. Ooh.
Everyone is now officially awake.
All right. Hello. I'll low talk. Hi, everyone. My name's Jake. This is Ryan. We both work at NSelect and are placed at Liberty in the D Hub there. And yeah, this is our presentation on JavaScript in space.
Exactly. So as Jake has mentioned, our talk is on JavaScript, one of the two things we love a lot, the other being space exploration. So Jake and I wanted to become astronauts, but as it turns out, you need to be a naturalized citizen of the United States in order to do that, or you have to learn Chinese or Russian, which we weren't prepared to do. So we did the only logical thing we could, and we decided we're going to make our own space company, but we're going to start small and simulate things a bit first. So the simulation engine we chose is Kerbal Space Program. Just by show of hands, has anybody actually played Kerbal Space Program?
Yeah.
Cool. Good. I wish I had prizes for you all. So for those of you who aren't familiar with Kerbal Space Program, you get put in charge of your own space center, the Kerbal Space Center, which is on the planet Kerbin. Kerbin is an Earth-like planet. It's got the same gravity as Kerbin, but it's a lot smaller in radius. This is actually done for a few very good reasons. The first one is it takes around about 10 minutes on average to get to orbit around Earth. But in Kerbin, it's only about 2 to 3 minutes. So if you have to spend 10 minutes every playthrough just to get to orbit, you're pretty much never going to leave the solar system. The other thing is decimal precision. So KSP is written in C#, but at the end of the day, there's only so much memory that you can use. So if you are traveling out far in the solar system, the decimal precision errors get to the point where sometimes you're traveling faster than the speed of light, and the physics engine gets very upset with you. So planet Kerbin is inhabited by little green men known as the Kerbals. Here we have three of the most famous, Bill, Bob, and Jebediah. And a most recent addition, but very important, is the hotshot pilot Valentina. She was added very recently and is very critical to the game. So in the game, you are able to build ships. You get a whole bunch of different parts, and it's up to your creative side to build some crazy monstrosities like this one. You also get a lot of very strange vehicles like this. The sky's pretty much the limit. Once you've built your craft, you get to fly it, explore strange and interesting new places, and gather that tasty, tasty science.
It's a cheese. It's cheese, right?
It's pudding.
Oh, it's pudding. Okay.
Yeah, the min is made out of minimus is made out of pudding. If you're lucky, you get to return back to Kerbin with all that tasty science, which you can then use to unlock a whole bunch of other parts. These parts allow you to go further out into the solar system, which is quite big. And there's also a sandbox mode. In sandbox mode, it's kind of like Minecraft. You can pretty much do whatever you want. You can explore. These guys think, oh, okay, they're not going to go to space today by the looks of things, but as you can see, there's a lot of creative freedom. And a lot of dead Kerbals. But it's okay, in sandbox mode, they keep respawning.
Kerbals never really die.
No, they just become legends. So the game itself was made by a Mexican advertising agency called Squad. The guy actually made it in his free time, and it was heavily influenced by the community. It grew to the point where he was able to approach his bosses and say, hey, I think there's something here. There's lots of people using this. Can I have some actual work time to work on it? And at the height of their core development, they had about 10 developers across the world working on it. The game itself is written in C#, it's cross-platform, it's even on console nowadays. But getting back to our original plan. Here we have a photograph, a real-life screenshot, of the inside of the cockpit of the space shuttle. So as you can see, there's a lot of dials and knobs and doohickeys and MFD displays and joysticks and such. And when you play Kerbal Space Program, you kind of only have a mouse and a keyboard. So we said, we'll solve this problem first in our simulator. And we embarked upon building an actual control board. But first we needed to interface with the game. So we looked at a few options. One of them was KOS. This is an in-game language. It's based on Kerbal stupidity. So the syntax is quite basic and not that great to work with, but still very cool to have a lot of fun with. Then we found krpc. This is a library that somebody else has written. It's a mod. The game is very extensible, lots of mods. And it has a server that runs next to the game, and it listens for incoming connections from the web or on localhost. The problem was there was only a library in Python, Lua, C++, and C#, and I think Java as well, which we didn't really want to do. We wanted to do this in JavaScript, because everybody knows JavaScript is the best for mathematical calculations. So the first step on our journey after that was to write our own library.
Ryan's being very generous there. He wrote it, I did QA mostly.
He was a very good QA specialist. So once we had the library up and running, we actually worked closely with the original modders, and it's now part of the official documentation. And I actually wrote I generated documentation. Thank you. So go check it out. It's on NPM. You can add it into all your line of business applications. I will be looking at hosting some versions of the game, maybe running on Azure. Maybe we'll put them in a Docker. That's cool. So the library itself uses WebSockets, which is quite important because you want to be able to read out the state of the game, and you also want to be able to post updates to maneuver your spacecraft around. The key thing that's important here is it uses a library called Google Protobus, which allows us to basically send very small messages across the wire in a very fast way. The schema is not included in the message as it is in JSON, and instead the client and the server have a contract that they agree upon. There's some benchmarking that's been done where you can see how well Protobus perform in .NET. It's similar in Node, as well as the size of the payload. So onto our journey. Ultimately we want to get to space, but we've said Elon Musk has sort of gone along this path already. Let's follow in his footsteps. So we looked at the Grasshopper program. It basically allows a liquid fuel rocket to take off from the launch pad, hover for a little bit at varying altitudes, and then make a suicide landing burn back to the launch pad. Ultimately, we wanted to also go fly to space. So this is just the first step along the road.
Can I just say, yay, SpaceX?
So we had to learn some orbital mechanics. And there was a lot of different ways we could have done this. We could have read books and stuff, but we chose to play Kerbal Space Program, and I think we've got a firm grasp of it now. The first step along the way is to basically just hover. So hovering is actually not that complicated of an equation to do. We have Newton's equations of motion that help us. So we've got force equals mass times acceleration. The only tricky bit here is all three variables are changing constantly. So the force that you need to exert from the rocket has to change based on the mass of the rocket, which is changing as you burn up fuel, and the force of gravity, which is the acceleration component, is changing as you get higher. Interesting fact, a lot of people think that when you are in orbit, like let's say at the ISS height, that you are not experiencing the force of gravity, but actually it's about 90% of what you would experience at sea level. But then why do objects seem to float in space? It's because you're in free fall. So if you were to drop a feather and a cannonball in a vacuum, they'd both land at the same time, but from the perspective of the cannonball, the feather is basically floating. So that's why objects appear to float. So first thing along on our hovering, we tried manually hovering, and that's our puddle jumper spacecraft over there. As you can see on the throttle on the left-hand side there, it's moving quite violently, and the speed's not that constant. There were also some technical difficulties. A few rockets were destroyed, a few billion Kerbal Space monies.
It happens.
After that, cool, we decide we know how maths works, and we tried that, which, as you can see, is quite a lot of oscillation. So we did a bit of research, and apparently this problem has been solved quite well before. Those of you engineering students around here would recognize the PID controller. Basically, the way I understand it is there's some sort of witch or demon that lives inside and tells you what to do. So for those of you who aren't familiar with it, you basically feed in a desired state. Like, I want my speed to be 0. Your current state, my speed is minus 1,000, and it keeps track of an error value and tells you what you should apply to your throttle in order to get to that desired state. All right, so time for a demo. So using the PID algorithm, we've got our game running over here, and we got the game running over there, and we've got a command prompt over there, and I'm going to kick off the script. So even though the communication is happening between the game and the server running on the the script running on the left-hand side 1,000 times a second, we only write to the console once a second because, as you can imagine, console can be quite slow. So we've deployed our grid fins a la SpaceX style. I'm just controlling the camera over here. You can see the speed and the throttle. It's a lot more gentle, less gravity forces. As you can see, the pitch and the roll and the max thrust, all of the values there are changing constantly. We've still got some oscillation, but I could tweak the PID stats there. And then we want to come in for a suicide burn. And all of that was done without any manual intervention. And our rocket has landed safely. And we can reuse it in future space.
Wait.
What did you do?
I did nothing.
Oh, no. Okay.
It's going straight for the vehicle assembly bay. Oh, God.
It's okay. It was insured. It's insured.
It's burning, Ryan.
How many Kerbals were in there?
I don't know. Wasn't it a probe?
It's okay. They'll respawn.
Okay.
All right. Cool. So, as you can see, mission completed. Cool. So Jake's going to take you through what he did on the mechanical side of things.
Okay, this is going to be difficult because I don't have a cool mic.
Plug it in there. So a standard USB cable plugged in, and we will start up the controller.
So we call this model here the Mark 1. It's built into a cardboard box. It's actually the cardboard box that the Arduino that runs the thing arrived in. I thought that was quite convenient. And it was a good prototyping board, and I got some joysticks set up there and an LCD and a couple of little toggle switches. And that's pretty much how it was for about 6 months, and then about a week ago we decided we should maybe try and make it look a little bit more professional. So I started trying to make it, and you can see it became a bit of a spaghetti monster, and it turns out I'm not very good at soldering or workshopping things at all, or drilling or anything. You can see some of the, like, I don't know, the extra drill holes, shall we say. And if you look closely, you'll also see that there's a lot of duct tape on the bottom of this. It's because I underestimated how much space wiring takes up, and when I tried to attach the base plate, I kind of broke all my soldering joints. so it's just kind of held together now. Plan stuff better, guys. And now we're going to try and show you a demo. Hopefully it works. It did 20 minutes ago, but electronics, you never know. My soldering is very dodgy. So yeah, let's hope for the best.
Do you want me to hold the mic?
Yeah. Okay, I'm just going to shout because, I'll try and talk like this. Okay, so first toggle switch. I'll start with the throttle. If you see the throttle there on the left of the nav bar, which is the big blue-orange ball in the middle, you can see the throttle is being adjusted here by this sliding of this potentiometer that I have here. All right, that's pretty cool. The joysticks, if you look in the bottom left-hand corner, you see these three sort of meters that give you your pitch and roll and yaw. Okay, so you can see I'm controlling the craft right now with the controller. Let's turn the lights off. We have these fancy disco lights that Ryan decided to put on, so I'm going to turn those off with my cool toggle switch. I'm going to engage the brakes, but that's not going to do much in space, but they're on. What else can we do? We can turn on our stability control and our reaction control, and then we've got some action group buttons. So I'm going to open the cargo door bay now. Now I'm going to extend our solar panels with another button, and let's start like folding out some other things. I think that one's on the other side.
Push them all at the same time.
Oh, same time? No. And yeah, it's all working. I'm very stoked about that.
There were bets about this.
We also have an LCD on the controller. It reads back data from the game, so you can have like your speed or whatever you want to display on there. But you guys can't see that all that well right now. Sorry about that.
All right, so we're pretty much out of time. If anybody's got any burning questions, we will be around and you can come and give us a shout. Thanks a lot, everybody.